Imagine a colossal, unseen ghost haunting the darkest, most freezing edges of our cosmic neighborhood. For decades, astronomers have been staring into the abyss, searching for a phantom world that behaves like a puppet master. Violently warping the orbits of distant icy rocks. We call it Planet 9, but after years of dead ends and frustrated calculations, the greatest game of hide and seek in human history might just be over, because we have finally stopped looking in the wrong way. And the world's most powerful observatories could be exactly what we need to unmask the culprit. For billions of years, our solar system has harbored a massive secret. Forget what you learned in school about Pluto. What we are dealing with now is a hypothetical giant planet. With a mass up to 10 times that of Earth. It resides so unfathomably far away, orbiting the Sun about 20 to 30 times further out than Neptune. That a single year on this world takes between 10,000 and 20,000 Earth years to complete. Because of this staggering distance, it has remained completely invisible to us. A mathematical ghost leaving only gravitational footprints in the dark. The first breadcrumbs of this cosmic mystery were dropped when researchers noticed something bizarre happening in the Kuiper Belt. A vast region of icy debris stretching far beyond Neptune. 6 known objects in this distant graveyard were moving in highly unusual ways. Their elliptical orbits were not only pointing in the exact same direction, but they were also tilted at a sharp 30-degree angle downwards compared to the pancake-like plane of our planets. The odds of this alignment happening by pure chance are astronomically low, at around 0.07%. Acting as a cosmic shepherd, clustering these distant space rocks together. So why have we never captured a direct image of this giant? The problem lies in how we were searching. For years, scientists were trying to spot Planet 9 by looking for the sunlight it reflects. But visible light has to travel billions of miles to reach the planet, bounce off its icy surface, and make the excruciatingly long journey back to our telescopes on Earth. At that extreme distance, a planet the size of Neptune would look 10,000 times fainter than normal. We were essentially trying to find a single, dim torch in an ocean of absolute blackness. But recently, a groundbreaking shift in strategy occurred. What if, instead of looking for reflected light, we looked for the planet's own thermal radiation? In infrared light, the planet's heat only has to make a one-way trip to our detectors, making it about 100 times fainter. By combing through decades-old infrared data from satellites like the 1983 Infrared Astronomical Satellite, and the Japanese Akari Observatory, astronomers noticed something genuinely incredible. Amidst the vast, empty blackness, they tracked celestial objects showing tiny, deliberate movements across a span of 23 years. After painstakingly ruling out the false wobbles caused by the Earth's own orbital trick of the light known as the parallax effect, they zeroed in on a single, highly compelling candidate. Suddenly, we have a target, and with the James Webb Space Telescope's unprecedented power, we might finally reveal where this giant has been hiding all along. Despite the incredible difficulty of distinguishing it from background stars. As the excitement around this potential candidate builds, the James Webb Space Telescope enters the fray as the ultimate tool to solve the mystery. You might wonder why a telescope capable of seeing galaxies billions of light years away struggles to find a planet in our own cosmic backyard. The reality is that in astronomy, apparent brightness is far more important than actual proximity. Because Planet 9 is situated anywhere from 400 to 800 astronomical units away from the Sun, it reflects almost no visible light. To put this into perspective, the Andromeda Galaxy appears about 12,000 times brighter in our night sky than Pluto does at its maximum brightness. Any reflected sunlight from a distant ninth planet would appear unfathomably faint after traversing the solar system twice, and distinguishing it from millions of background stars based on its slow orbital motion is an immensely difficult task. This is exactly why shifting to infrared observation is a complete game changer. Rather than relying on sunlight, astronomers are now hunting for thermal radiation. The research team from National Tsing Hua University recently pored over decades of archival data from the decommissioned infrared astronomical satellite and the Akari satellite. By searching for distant objects that moved slowly between the datasets, they successfully identified what they describe as the first good candidate. This candidate appears as a consistent, faint dot with matching colors and brightness, suggesting it is a single massive object. However, the scientific community is rarely without its debates, and this groundbreaking announcement was immediately met with intense scrutiny. Mike Brown, the Caltech astronomer who famously co-proposed the original Planet 9 hypothesis in 2016, stepped in to crunch the numbers. What he discovered threw a massive spanner in the works. Brown carefully calculated the orbit of this specific infrared signal. He found that the object would be tilted at a staggering 120 degrees from the flat plane of our solar system. This is drastically different from the 15 to 20 degree tilt originally predicted for Planet 9. Even more bizarrely, this extreme tilt implies that the candidate object would actually be orbiting in a completely different direction from all the known planets. So, what exactly is this mysterious object lurking in the dark? According to Brown, this severe mismatch does not necessarily mean it's not there, but it strongly suggests that it is not the Planet 9 we have been searching for. He argues that this newly proposed planet would simply not exert the specific gravitational effects on the Kuiper belt that led to the original hypothesis. Furthermore, if this new infrared signal is indeed a massive planet, it could not peacefully coexist with the originally hypothesized Planet 9. Brown's complex calculations reveal that the two massive bodies would make each other's orbits highly unstable over time. We are now faced with a fascinating scientific crossroads where this new candidate could represent an entirely different planet, one that might even disprove the original Planet 9 hypothesis altogether. So if the mysterious infrared dot discovered in the archival satellite data is not the Planet 9 we have been hunting for all these years, then what exactly are we looking at? The calculations reveal a fascinating and somewhat terrifying possibility. Our solar system might be hiding not just one, but multiple unseen worlds in its freezing, pitch-black outer limits. While Planet 9 was a massive cosmic shepherd clustering the orbits of distant icy rocks, astronomers have recently begun pointing to another hidden suspect entirely. Tentatively dubbed Planet Y, this alternative candidate is thought to be smaller, perhaps somewhere between the mass of Mercury and Earth, and hiding roughly 100 to 200 astronomical units away from the Sun. The mathematics suggest that rather than clustering objects together, this smaller world would act like a tilted playing field, slanting the orbits of these distant icy bodies in unison. The odds of these objects all tilting in the same direction by chance are astronomically low, at around 2.24%. If both hypothetical worlds turn out to be real, it means our entire understanding of the outer solar system fundamentally incomplete. We could be looking at a complex system of hidden planets that has been quietly pulling the strings in the dark for billions of years. This is precisely where the James Webb Space Telescope becomes our greatest asset, yet also faces its most daunting challenge. Webb is unparalleled in its ability to peer through the cosmos in the infrared spectrum, vital because these planets reflect almost no visible sunlight. Any light from the sun has to travel billions of miles out, hit the planet, and make the excruciating journey all the way back. However, the James Webb Space Telescope has a very narrow field of view. It is akin to looking at the sky through a drinking straw. Trying to find a dim, slowly crawling tortoise of a planet against a blinding backdrop of millions of stars is a monumental task. To finally unmask these worlds, astronomers are anticipating a revolutionary tag-team approach with the Rubin Observatory. This facility is equipped with the largest digital camera ever built, acting like a gigantic, high-resolution security camera for the heavens. By mapping the southern sky every few nights, the Rubin Observatory will spot the minuscule movements of faint objects that others missed. Once this dragnet flags a target, the precision of the Webb telescope can zoom close to analyze the thermal signature and confirm our find. We are standing on the brink of a discovery that will permanently rewrite our maps of the solar system. But what happens if these new observatories reveal something even stranger than a missing planet?